testing equality with the assert equals and assert not equal macros. A common way to test functionality is to compare the result of the code under test to the value you expect the code to return to make sure they're equal. You can do this using the assert macro by passing it an expression using the equal operator. However, this is such a common test that the standard library provides a pair of macros, assert equal and assert not equal, to perform this test more conveniently. These macros compare two arguments for equality and inequality, respectively. They'll also print the two values if the assertion fails, which makes it easier to see why the test failed. Conversely, the assert macro only indicates that it got a false value for the equal expression, not the values that led to the false value. Okay? So what they're saying here is that there's going to come a time you want to test that something is equal to something else or something is not equal to something else. And because how common this procedure is, they have created macros for us. And the benefit of using these macros as opposed to using assert and putting equal operator in it or not equal operator is that when these fail, they will show us the values that we put in that led to the failure. In listing 11.7, we write a function named add2 that adds 2 to its parameter and returns a result. Then we test this function using the assert equals macro. I guess we can just add it. Oh, no, they have one test, so they just erased everything, didn't they? Okay. We no longer need this rectangle. Rectangle gone. We no longer need these two tests. Gone. But I need that closing bracket. And I'll keep that test there. So we have a public function add2 that has a parameter a, that's I32, and it returns I32 presumably. This is seemingly the function that we talked about in the introduction. Finally writing it out. Take in an integer and then add 2 to it. Now we have a test that's going to assert that we added 2. It adds 2. Assert equal 4. Add 2, and then we pass in 2. One thing to note is how explicit these test names are. That's just a good practice so that when you're looking at test output, you know exactly what the test is supposed to be doing without having to dig into the code, because the output can be rather large if you have a lot of tests. And we ran this test, it passed. Let's check that it passed. It did. Moving onward. The first argument we gave the assert equal macro was 4, right? Here's 4. Is equal to the result of calling add2, 2. The line for this test is right there. We saw that here. And the OK text indicates that our test passed. Let's introduce a bug into our code and see what it looks like when a test that uses assert equals fails. So we're going to change the implementation. They did add 3. Okay. And now we're going to see what the failure looks like. So, that's good. So they have the left and right, and they have the equal sign, right? The assertion failed. And they say that on the left there was a 4, and on the right there was a 5. So it's really explicit about why these things are not equal. That's good to see. And then it has a list of failures, yada, yada, yada. Moving onward. Test it again, 4, 5. Our test caught the bug. The it adds 2 test failed, displaying the message assertion failed. Left equal right, and showing that the left was 4 and the right was 5. This message is useful and helps us start debugging. It means that the left argument to assert equal was 4, but the right argument where we had the add 2 was 5. Note that in some languages and test frameworks, The parameters to the function that assert two values are equal are called expected and actual, and the order in which we specify the arguments matters. However, in Rust, they're called left and right, and the order in which we specify the values we expect and the value that the code under test produces doesn't matter. We could write the same assertion in this test as assert equals add 2 to 4, which would result in a failure message that displays left and right got switched, that the left was 5 and the right was 4. I'm not exactly sure why they have to mention that, but I guess if you come from the language where the order does matter, the order doesn't matter here. Assert not equal macro. The assert not equal macro will pass if the two values we give it are not equal, and fail if they are equal. This macro is most useful for cases when we're not sure what a value will be, but we know what a value definitely won't be if our code is functioning as we intended. For example, if we're testing a function that is guaranteed to change its input in some way, but the way in which the input is changed depends on the day of the week that we run the test, the best thing to assert might be that the output of the function is not equal to the input. All right, so right here they're talking about the assert not equal, and the assert not equal is just a macro that checks that the left side is not equal to the right side. And they give you example. They gave us an example of when we might use this. So their example is we have a function. This function takes an input. We know that it is guaranteed this input is going to be modified. However, the modifications that are made to this input vary from different, let's say, days of the week, time. There are many things that manipulate it or make this change unpredictable. The only thing that is predictable is that this thing that we input into this function is going to be changed. So then we can just test that the input is not equal to the output. Personally, that doesn't seem like a great test. And I got a kitten trying to run over the keyboard. Personally, that doesn't seem like a great test because it doesn't really test what you're expecting, or because you can't really check an expected output. But at the same time, if this is the best you can do in that situation, by all means, do it. It's better than nothing. Under the surface, the assert equal and assert not equal macros use the operator equal and not equal, respectively. When the assertion fails, these macros print their arguments using debug formatting, which means the values being compared must implement the partial equal and debug traits. All the primitive types and most of the standard library types implement these traits. For structs and enums that you define, you need to implement the partial equal to assert that values of those types are equal or not equal. You'll need to implement debug to print the values when the assertion fails. Because both traits are derivable traits, as mentioned in listing 5.12 and chapter 5, this is usually as straightforward as adding the derived partial equal debug annotation to your struct or enum definitions. See Appendix C, derivable traits, for more details about these and other derivable traits. Oh my god, that was a mouthful. So in summary, a lot of this stuff it's important just to note, but it doesn't really mean much. So they're saying that the assert equal and assert not equal, under the hood it does a comparison. In order to do a comparison in Rust, whatever you're comparing has to implement this trait, the partial equal. And if you want something to be able to print out, like if there's an error and it has to be printed out the screen, then you have to implement the debug trait, or I guess the display trait, technically speaking. But yeah, debug will work fine. So if you're going to write your own code that has your own structs, you have to make sure that your structs implement both of these traits, given that you want to use the assert equal and assert not equal macros, respectively. Adding custom failure messages. This is very needed. You can also add a custom message to be printed with the failure message as optional arguments to the assert equal, and assert not equal macros. Any argument specified after the one required argument to assert, or the two required arguments for assert equal and assert not equal, are passed along to the format macro discussed in chapter 8 in the concatenation with the plus operator, or the format macro section. So you can pass a format string that contains the curly brackets, placeholders, and values to go in those placeholders. Custom messages are useful to document what an assert means when a test fails. You'll have a better idea of what the problem is with the code. So here, we're just going with something that's standard in terms of testing, is the ability to pass in a custom message so that when an assert fails, you can have some context of what is being tested or where this test is, or some information that helps you identify the problem much faster. And then we're writing an example. For example, let's say we have a function that greets people by name, and we want to test that the name we pass into the function appears in the output. And like with everything else, we rip this apart. So no more you. And I need that back. And no more you. So we'll have this new function. We're calling it greeting, right? We have a name. We pass in a point to a string or string literal, and it returns a string, capital S string. Noted. And we're using the format macro to do that. Format hello, and then we're passing the name into the string. Okay, so just returning hello and the name that we passed in. So in terms of testing, greeting contains name. Okay, we need to make sure that the greeting contains a name. So let result equal greeting, and the name we use is Carl. And now we need to assert that that name is in the result. So assert, not popping up still, result dot contains Carl. And everything looks like it's a go. One test ran, one test passed, everything else is null. The requirements for this program haven't been agreed upon yet, and we're pretty sure the hello text at the beginning of the greeting will change. We decided we don't want to have to update the test when the requirements change. So instead of checking for exact equality to the value returned from the greeting function, we just assert that the output contains the text of the input parameter. Okay, so what they're saying here is, in a common situation, you're writing a function, right? And you know what the function is kind of going to do, but the final text or copy has not been agreed upon. So you don't know what the exact output is going to be. However, you know that, at least in this example, the input that we're using, or the input that we're getting into this function, is going to be in the final output, regardless of how things change. So, in effort to write this test once and not have to change it each time the requirements change, in the test, we just check that the information that was passed into the function exists in the output. So if we change this to, let's say, hello to you, and then run it again, it passes, because the only thing we're checking for is that Carl exists in the final output. And continuing with the pattern, we're going to introduce a bug into this code. So let's take out name. And they only have hello. Let's see what it says. So we get the test failed, we get the output, we get the line, and that's about it. The result just indicates that the assertion failed and which line the assertion is on. A more useful failure message in this case would print the value we got from the greeting function. So let's change the test function giving it a custom failure message made from the format string with a placeholder filled in with the actual value we got from the greeting function. So what they're saying here is that in our test failure, which we can see here, we know what line it failed on, we know why it failed. I mean, the assertion was false, but we have no context as to what this means. And that's what we're going to add now. With the custom message, we're going to add context to give us some clarity into the situation. So right now, they just did a custom placeholder, right? So I have comma. Ooh, no, not there. Wait, where are you? You're that. Oh, no, it is there. Tab. The message says greeting did not contain name. Value was, okay, greeting did not contain name, comma, value was, result. Did they add a colon at the end of this? Because I don't think it was there originally. Was it? Have I just been not adding it? No, it was there. Maybe I accidentally deleted it. Okay. So we have a custom message, and let's see how that goes. So we have a test failure. And in the output, the standard output of the test failure, we have the panic, and then we have our message right here. Greeting did not contain name. Value was hello. Yeah, at least that's some context. I mean, things could be better, but that's something. Now we run the test and we get more informative error message. And greeting did not contain name. Value was hello right there. We can see the value we actually got in the test output, which would help us debug what happened instead of what we were expecting to happen. Yeah, context. Context is going to help us debug this. Moving onward. Checking for panics with should panic. Okay. In addition to checking that our code runs the correct values we expect, it is also important to check that our code handles error conditions as we expect. For example, consider the guess type that we created in chapter 9, listing 9-10. Other code that uses guess depends on the guarantee that guess instance will contain only values between 1 and 100. We can write a test that ensures that attempting to create a guess instance with a value outside that range panics. So here, what they're going over is just a scenario which we already actually wrote up of where we can use should panic. So the guess type that we wrote in chapter 9, it only accepted values between a specific range, and if it wasn't in that range, it panicked. This test is going to assure that when we put something out of the range of 1 and 100, guess panics. We do this by adding another attribute, should panic, to our test function. This attribute makes a test pass if the code inside the function panics. The test will fail if the code inside the function doesn't panic. Alright, so listing 11-8 shows a test that checks the error conditions of guess new happened when we expect them to. And we're writing guess, and we're erasing everything we have. So you go away. You go away. And we're writing guess. So public struct guess value I32. Implementation block guess public function new. We're taking a value that is I32, and we're going to return an instance of guess. And if the value is less than 1 or the value is greater than 100, we panic. And we have a message saying guess value must be between 1 and 100. Got a period. We got the value. Yeah. Oh, I think it's red because we haven't finished the function. It's not returning anything yet. So outside of that, if it does not fall into this if block, we say we create an instance of guess with the value. I guess technically speaking, we could do like value equals value, right? No, we're just passing value. Okay. Doesn't look like the comma is needed either. And now we write a test for it. We already have the super. Oh, we have to add another attribute. This one is the should panic. I mean, at least this is explicitly stated. I like how explicit it is, like open. You can easily see if test should panic because it's at the top of the test. Should panic. Function greater than 100. Guess new 200. And we have an import that we're not using. Outside of that, our test passed. So we have the running test greater than 100. Okay, which means that in this test, this panicked, and the panic, I guess, was caught. I don't know under the hood what this does. They might explain it, but it just checked to see if it panicked. So we can also see what happens if this doesn't raise a panic or doesn't panic. 20 works. We see that our test results failed. We see one test ran, failures. There's nothing here because there was no standard output of a failure. Makes sense. Nothing panicked. And then we have the list of failed tests, which is just this one. And I'm not sure if we can add any custom messages to it. Because right now, we just know that it should have panicked, but that's it. That's pretty bare bones. So good, let's introduce a bug. Okay, how did they introduce their bug? They said value is less than 1. If the value is less than 1 or value greater than 100, they took off the second part and only had that part of the condition. Thus, their code didn't panic and they have the same error message. We don't get a very helpful message in this case. But when you look at the test function, we see that it's annotated with the should panic. The failure we got means that the code in the test function did not cause a panic. Tests that use should panic can be imprecise because they only indicate that the code has caused some panic. A should panic test would pass even if the test panics for a different reason from the one we are expecting to happen. So these two lines say something that's kind of alarming. So it notes that the should panic tests are imprecise. And they're imprecise because yes, you're checking for a panic. Yes, you are expecting a panic. But if the code panics for a reason other than the one you were expecting, these tests still pass, at least as written as it is now. To make should panic tests more precise, we can add an optional expected parameter to the should panic attribute. The test harness will make sure that the failure message contains the provided text. For example, consider the modified code for guest in listing 11-9, where the new function panicked with different messages depending on whether the value is too small or too large. All right, so down here we have two different panics. So let's say if value is less than 1, we say the value must be greater than or equal to 1. And we probably still use this guy, right? Value must be greater than or equal to 1. Then over here we say got yada yada yada. Cool. And then we have an else if the value is greater than 100. We panic with a similar message. Copy, paste, enter. The value must be less than or equal to 100. And then we got value. And then we have to change this back to what they had. Say 200. And in the test, right here, I see they pass expect here. Expect equal to, and they put the string. Is this truly equal? I mean, this is contained in it, but let's see what happens. So the test pass. So the expect is not doing an equality check, it's doing a contains check because the actual message says guess value must be less than or equal to 100, comma, got, and it has the value. But because we have the expect here, it does inform us which error happened. And it helps us make the test more precise because now we know that the panic that we got is associated to the panic that we wanted. But I have to admit that this syntax is kind of ugly. I mean, it's explicit, it's on top of it, but depending on the error messages, this could be really long. This test will pass because the value we put in the should panic attribute's expected parameter is a substring of the message that the new guess : new function panics with. We could have specified the entire panic message that we expect, which in this case would be guess value must be less than or equal to, comma, got 200. What you choose to specify in the expected parameter for should panic depends on how much of the panic message is unique or dynamic and how precise you want your test to be. In this case, a substring of the panic message is enough to ensure that the code in the test function executes the else if value greater than 100 case. So yeah. So like I was saying before, the expected is a substring of the actual panic message, and how much of the panic message you put into the expect parameter is up to you. It's preference. To see what happens when a should panic test with an expected message fails, let's introduce a bug into our code by swapping the bodies of the if value less than 1 and the else if value greater than 100 blocks. So yeah, let's do that real quick. And I don't think we have to swap them per se because we only tested one. We just have to make this one different. I'm just deleting some of the words. So it's no longer a substring. And now we have a failure. Oh, wait, it still passed? Did it still pass? Was some of the words deleted? I may have an error in my syntax. Let's look at this expect. I do have an error. It's expected. Ooh. So one thing to note, if you write expect and not expected, it doesn't work. This is just ignored. If you have typos in your attributes, they are ignored. Ouch. Okay. I guess that makes sense. Everything's working as expected. We have the error message, and we say the panic string did not include expected string. And this is the expected string. Cool. Moving onward. This time when we run the should panic test, it will fail. And we already looked at this message. It's the same. We have the note panic did not include expected string. And then you put the string there. The failure message indicates that the test did indeed panic as we expected. But the panic message did not include the expected string. Guess value must be less than or equal to 100. The panic message that we did get in this case was guess value must be greater than or equal to 1. Got 200. Now we can start figuring out where our bug is. Alright, moving on to using result, TE in tests. So far, we've written tests that panic when they fail. We can also write tests that use result. Here's the test from listing 11-1. Rewritten to use the result and return an error instead of panicking. Alright, but that means we also need the function from that section as well. So let's just erase that. Erase this. And I guess it's public function. What is it called? It works. Oh, no. They didn't call it function. They just wrote it explicitly. My bad. So, yeah. We create a test function. Hashtag. Here's their attribute. Test. Function. It works. And this is going to return a result. Interesting. String. Okay. If 2 plus 2 is equal to 4. Okay. And return the empty. Else. Error. And return a string. I see. This is kind of verbose, but it makes sense. And it's much more explicit and easy to write your error messages or your custom messages using this method. 2 plus 2 does not equal 4. And that's a typo in the name. So let's run the test to make sure everything works. Yes, we have the test passed. And make this 3 to make an error. To see what it looks like when it errors out. We have the assertion error, left and right. And we have the error message right here, error. 2 plus 2 does not equal 4. Oh, that's cute. That's cute. That is really cute. And it still gave us a left and right. The it works function now has a return type, result. nothingness, and string. In the body of the function, rather than calling the assert equal macro, we return an OK when the test passes and an error with a string inside when the test fails. Writing tests so that they return a result enables you to use the question mark operator in the body of test, which can be a convenient way to write tests that should fail if any operation within them returns an error variant. And if you recall, I believe the question mark, if it's okay, does nothing, but if it's not okay, throws an error or panics, something along those lines. You can't use the should panic annotation on tests that use the result. Instead, you should return an error value directly when the test should fail. Okay? Now that you know several ways to write tests, let's look at what is happening when we run our test and explore the different options we can use with cargo test. And that is the end of this section. That was long, but it's very informative and useful. Rather basic, but testing is needed. Testing is always needed. And with that, peace.